Find the inverse function of f of x equals the square root of 1 minus x squared for x between 0 and 1, including the 0 and the 1. So first of all, let's write the equation in two variables for x, for f, and it will be y equals the square root of 1 minus x squared, and we have a restricted domain explicitly given because without restricting the domain, the square root of 1 minus x squared would not be 1 to 1. So it needs to be restricted to the right side of the y-axis. Now notice that also when you restrict the domain from 0 to 1, you also restrict the range from 0 to 1. And the reason for that is because when x is 0, y is 1, and when x is 1, y is 0. And so now we're ready to take and solve the equation for y, or the equation y equals the square root of 1 minus x squared for x instead of for y. So I'll start by squaring both sides. Then adding x squared to both sides. Now, some of you may recognize this. This equation is the equation for a circle at the origin with radius 1. But with the restrictions that both x and y go from 0 to 1, it is the top right quarter of the unit circle, the part of the circle that's in the first quadrant and the adjacent axes. And so we continue here. Our goal is to solve for x, so subtracting y squared from both sides, get 1 minus y squared. And because x is strictly positive, we can, when we take the square root of both sides, we do not need a plus or minus. It's strictly non-negative. We don't need the plus or minus. So we get x equals the square root of 1 minus y squared. And now, since we've solved for x, we can interchange the x and y to get the equation for f inverse. And then when we replace y by f inverse of x, we get the square root of 1 minus x squared. But that would not be 1 to 1 unless we include the restriction that was on y. The y was the range was between 0 and 1, so the domain has to be between 0 and 1 of the inverse. Now, if you look, we have the same function for the inverse as we had for the original. The reason is that when we think about the graph, the original graph is symmetric with respect to the line y equals x. And so this time the inverse of the function is itself. It only goes between 0, 1 and 1, 0.